So today we're doing 1.1 linear and rational equations. Linear equation is of the form ax plus b equals 0, but most equations don't look that way. A and b are real numbers. A can't be 0, otherwise we won't have a linear equation because we're trying to solve for x, and x would be gone. We are going to come across three different types of equations, and this is throughout the whole entire college algebra. We would get an identity in which we end up having a true statement. So for instance, 5 equals 5. Then we would answer it with all reals and using negative infinity to positive infinity. A conditional one is the one we're going to come across the most. That's when we have an equation with at least one solution. So you might get x equals 5. Okay, so they're telling us exactly what x it can be. And then we have a contradiction. And so this is a false statement. So we would end up with 4 equals 5. And of course, that's ending up to be no solution. And that's the way I want you to write the answers. So this is a true statement. It does not have to be 5 equals 5. It can be any two numbers as long as they are equal or true. And the same thing down here. These are false statements. It doesn't have to be 4 equals 5. It can be anything as long as it's a false statement. Then it gives a no solution. All right, we're going to hit this kind of this kind of instance here. We're going to hit this in another lesson, so I'm not going to do that right now. So let's go on down. Oh. All right, and we're just going to go ahead and we're going to start solving. So our first equation is a formula, and a formula contains more than one variable, but you're trying to solve for it. So for instance, if you have like 10,000 different items and you need to find, we'll say that the big A represents the area, Y represents the length, Z represents the width. Let's just say that, okay? And so, and this is for some object that we have, and we have 10,000 items. Well, we don't want to have continuously solve this over and over and over again after plugging in those numbers. So what we do is we solve for one of the variables. In this case, they want us to solve for Z, and then we can just plug the numbers in and it's straight basic math. So that's the reason why we adjust formulas and solve them for a different letter. So in this case, in order to solve for Z, we've got to get rid of the 5 and we got to get rid of the Y. So to do that, I am going to go ahead and I'm going to subtract the 5 to both sides. Now the 5 is not the same as the A, so I'm going to write this as A minus 5 equals negative Y plus Z. Now, I still have to get rid of the negative Y. So again, I'm going to undo it. So that means I'm going to add Y. Well, again, adding Y to the left-hand side, that's not the same as any of those. So the way I'm going to write it is A minus 5 plus Y is equal to Z. And then when Z is completely alone, or whatever letter they're asking for is completely alone, then you've solved the problem and you leave it as is. And you'll have many different formulas to use. We'll talk more on formulas as we go throughout the quarter. All right, here we have an equation and we want to solve for V. So the first thing that we're going to do is get rid of the parentheses. And to do that, we're going to distribute because we got minus signs inside the parentheses. So this will give us 5V minus 15 equals negative 9V plus 27. Now you want to get your V's together and get your numbers together. What I like to normally do, I like to normally move my V's together first so I don't get caught in a trap. And I'll show you what that trap is here in a little bit. So I'm going to add 9V to the other side. And I'm going to take it slowly for right now. I will bump up. If you can move them both at the same time, go ahead, be my guest. I will bump up. All right, so this will give us 14V minus 15 equals 27. So now I go ahead and move the 15. And so that's going to give us 14V is equal to 42. And then divide off the 14. So that's 42 divided by 14, which does not go nicely. So we go ahead and reduce it. We can reduce it by 7. So that's going to give us 6 over 2. Well, I lied. It does reduce nicely. So that ends up giving us just 3. So this is a conditional statement. You will not have to write these on the test, but Alex may ask you for it. Okay, so this is a conditional statement. Our answer is 3. So you just circle in that letter. All right, so what trap was I talking to you about up above? So say, for instance, you have 2V equals V. A lot of people think that this is no solution because you can't have 2 equaling 1, or they divide off the V. Well, you can't divide by a letter because you don't know if that letter is 0. So you've got to get these together first. So you would subtract V to both sides. And so this ends up telling you that V is truly 0, which gives you another conditional statement. Okay. So don't get caught in this trap. Move your letters first. If you move your letters first, then the only way you're caught in this trap is if they only give you this problem. All right, so we've got another equation to solve for. Again, the first thing we get rid of is the parentheses. So I'm going to distribute the -6. And at any point in time, if you feel like you want to try it yourself, you could stop this video and then go try the problem yourself. And then start the video again and see if you got it right. So we have -6 parentheses, W plus 1, close parentheses, equals 2 parentheses, 1 minus 3W, close parentheses, minus 7. So here we'll distribute the -6. So this will give us -6W minus 6 equals 2 minus 6W minus 7. Now, we've got a lot of terms going on here. So we want to go ahead and get our like terms together, which we've got way too many on the right-hand side. So I'm going to put the 2 and the -7 together because those are like terms. So this would give us -6W minus 5. Well, again, like I told you above, I like to get my variables together first. So I'm going to go ahead and add 6W to both sides. Well, the problem is when I add 6W to both sides, they go away. So that leaves me with -6 equals -5. Well, that's not a true statement. -6 does not equal -5, so that ends up giving us no solution. And so again, if we had done this and we ended up, we'll do a what if over here. If we had ended up with -6 equals -6, then that's a true statement. And so that gives us an answer of all reals. And so we would answer it negative infinity, positive infinity. So if it was a true statement, then we would answer that. But since it's a false statement, we answer no solution. All right, we're going to get into absolute value equations. When you do absolute value equations, your absolute value has to be completely alone. If it's not completely alone, then you've got to get it alone first. Okay. All right. I'm going to start with something a little basic. So let's say we have the absolute value of x is equal to 7. Well, in this case, your x, which is inside the absolute value, could be 2 possible answers. Your x can be either 7 or it can be -7. So inside, we're concerned about what values can it be inside the absolute value, because both of those will bring us back up absolute value of +7. Your absolute value must always equal a positive number. If your absolute value does not equal a negative number, it is no solution, and you write no solution and then go on to the next problem. So this problem that we have here, the absolute value of x minus 4 equals negative 4. In this case here, we have an absolute value equal to a negative number. Well, an absolute value cannot equal a negative number. So this is a no solution situation that I was just talking to you about. Okay. So if you see that your absolute value is equal to negative 4, then you automatically write it to no solution. But the absolute value has to be completely alone. So for instance, if we had negative 5 plus the absolute value of x minus 4 equals negative 4, we can't claim no solution on this because we got junk sitting out front. We got to get rid of that junk first, which is the negative 5, before we can go ahead and say, okay, let's go and work the problem. So I would add 5 to both sides. And so this will give us the absolute value of x minus 4 is equal to 1. Well, that's where we determine whether or not it's no solution. And so because an absolute value is equal to a positive, yes, we can go further. So we say, okay, well, what's in the absolute value can be 1 or it can be negative 1. So we set up two equations. So I have x minus 4 equals 1, or I have x minus 4 is equal to negative 1. And I solve this out. So the first part, that's going to give me x equals positive 5. The second part is going to give me x equals 3. These two answers are normally not the same. If you end up with them being the same, then something went wrong. You probably forgot the negative or whatnot. So we've got two answers coming out of this, which is 5 and 3, not negative 3, 5 and 3. So keep that in mind that if your absolute value is all alone and equal to a negative number, then it goes into no solution. But if you have junk on the outside, then you need to get rid of your junk and then determine whether or not it's going to be a no solution or do I go further. So similar to our last problem, we have the absolute value of 3 minus 2x, and then plus 5 is on the outside of that, equals negative 1. So that plus 5 is our junk. So we've got to get rid of that junk before we can say, oh, it's not going to work or it is going to work. So we have the absolute value of 3 minus 2x is equal to, if we subtract 5, that's going to give us negative 6. Now we see, oh, the absolute value of 3 minus 2x cannot equal negative 6. So we instantly get no solution on this. Now, not all these cases will come up to be no solution. I just want you to understand that. The fact that these two examples did is just because of band planning on my behalf. And so once you get the absolute value, if it's equal to a positive number, then you go into the two equations like I showed you right here. And again, they could start it out with the absolute value and it be a positive number. Let's do one like that, just so you've got an example like that. So we'll do a what if. I like doing what ifs. What if the absolute value of 3 minus 2x was equal to 6? Okay, just starting it off, not having any junk outside, just as the problem itself. So we would say, okay, what's inside can be 6 or negative 6. So we get our two equations off of that. So we have 3 minus 2x is equal to 6, or 3 minus 2x is equal to negative 6. Now we solve out each one. So I would subtract 3 over here. So this will give me negative 2x equals 3. And then divide by negative 2. That would give us 3 over negative 2, or negative 3 halves. And don't worry about if it doesn't come out nicely, just leave it as a fraction. All right, over here we're going to subtract 3. So we have negative 2x equals negative 9. Again, I told you that the numbers should not be the same. And then dividing by negative 2, that's going to give us x equals positive 9 halves. So in that case, we would end up with two solutions of negative 3 halves and positive 9 halves. 2x minus 3 all over 14 equals -4. So now we're getting into rational equations. When we have rational equations, we got to watch our denominator because a rational equation is a fraction and it's a fraction equation. So we got fractions within our equations. Well, in the denominator of our fractions, we cannot have 0. So you need to check your denominator first to see if you have what's called an extraneous solution. And so you can label it as ES for extraneous solution. You can also say, okay, well, X cannot equal or whatever letter is in the problem. So in this case, X cannot equal, well, there's no X's on the bottom. So that means we have no restrictions going on. And you could just say none. We will be doing problems with restrictions before we get out of this lesson, so you will see that. All right, so here we're going to go ahead. We're going to get rid of the fraction. First, we get rid of parentheses, and then we get rid of any fractions or decimals. So I'm going to multiply by 14 to both sides. Well, multiplying by 14 to the left side, those 14s are going to divide out. So that's going to give me 2x minus 3. Remember, we wanted to multiply by 14 to get rid of the fraction. So don't do the 14 times the top and the bottom. Okay. On the right side, we've got -4 times 14. So that's going to give us -56. This is not an absolute value equation, so don't worry about the fact that it's -56. Just solve it out. It's a regular linear equation. So we're going to add 3 to both sides. So this will give us 2x equals -53. And then divide by 2, so we get x equals -53 over 2. Now, normally at the end of every fraction equation, you need to go check with your extraneous. But because our extraneous, we had none, then -53 over 2 ends up being our answer. If you don't list your extraneous down, then you need to check your answers back in the original equation. And if you look at this, -53 over 2, that's not going to be a nice check to plug it back in. So make sure that you list your extraneous down. And again, if you don't, then you must check. Okay. And again, you got to check in the original, so it's not an easy feat. All right, so let's look at this one. Okay. All right, again, it's a fraction and it's an equation. So we are going to have to look at our denominator first. And because it's a variable, then that means we have an extraneous solution. So we say x cannot equal. Well, what value can x not be? It cannot be 0. If it was 0, then we would have an undefined fraction, and we can't do that. All right. So now we multiply by our LCD. If you want to make a step of the LCD, you can do that. In our case, our LCD is just X. It's only listed down once, not twice. So we're going to multiply each one of these by X. And you could show it individually like I showed above, or you could do it as a big multiplication. So X times 12 over X is just going to give me 12. X times 15 over X is going to give me just 15. And X times -7 is going to give me -7X. So now I want to go ahead. I want to move my 15 because I'm trying to solve for X. So that'll give us -3 equals -7X. And then divide by -7. So I end up with X equaling 3 over 7. Well, again, I can't say that's my answer. I've got to check with my extraneous solution. And you may want to write that every time so that you don't forget. Well, the 3/7 does not match the 0, so that ends up being our answer is 3/7. So let's do another what if. Say, for instance, we ended up with x equals 0 in the answer. When we check it, that would not work, so our answer would be and end up to be no solution. And when I say check, I mean check with the extraneous. Okay? All right, so another what if. What if x was 0 and 3/7? Well, again, we check with our extraneous. The 0 would not work, and so our answer would just end up being 3/7. So there's three scenarios, but on every scenario, you've got to go back and check with your extraneous, however you list it, whether you list it as x cannot equal or whether you say ES, which to me, x cannot equal is actually better than listing ES because then you can see, oh, I can't have that. All right, so here's one with different denominators. So it kind of gets a little more challenging, um, but it's not terrible. And so anyhow, we start with our extraneous. X cannot equal. So 3 times x, well, if x is 0, then it can't be 0. I kind of jumped the gun on that. Sorry about that. The 12 is not going to give us an extraneous because there's no x associated with it. And then the x alone is going to give us an extraneous of 0. So we've got it all covered. We don't have to list 0 twice. Now let's go for our LCD. Well, if we look at just the 3 and the 12, the LCD between 3 and 12 is either the biggest number there or the bigger number. 3 is not the LCD because we got more than just the 3 with the 12. So in this case here, our LCD is going to be 12 because 3 goes into 12. And it's also going to be X because both of those X's pair up and get written down once. So now I'm going to multiply everything by 12x. Again, you can do it individually, or you can do it as one big multiplication. I'm doing it individually here because I want you to see what's going to happen. So 3x crosses off with the 12x, leaving us 4. So we're going to have 4 times x minus 2. On the second one, the 12s cross off, and that's going to leave me with plus 1x or x. On the last one, the x's cross off, which is going to leave me with just 12. Now we get rid of our parentheses, so that'll give us 4x minus 8 plus x equals 12. Okay, combine our like terms. So 4x plus x is going to give us 5x minus 8 equals 12. You can move the 8 at the same time if you want to. All right, now we add the 8 to both sides. So that'll give us 5x equals 20, which means x ends up being 4. So again, I take that 4 and I compare it with my extraneous, and it does not match. So that tells me that x equals 4 is my answer. So 0 is not always your extraneous solution. It depends on what your denominator is. So in this problem, we've got 3 all over y minus 4 equals negative 4 all over 3y minus 12, and then plus 2. So before we can go and find out what our extraneous are, we need to see if we can factor our denominators. In the previous ones, we didn't have to factor them because there was no plus or minus in the denominators. So y minus 4, we can't factor that, so that's fine the way it is. 3y minus 12, we can pull out a 3, and that leaves us with y minus 4. And I'll never use that 3y minus 12 again. I'm going to use it as 3 times y minus 4 instead. All right, so we do our extraneous. Keep in mind this is y can't equal because I've changed my letters to y instead of x. So on the first one, y cannot be positive 4 because if you use positive 4, 4 minus 4 would give you 0. So y can't be positive 4. In the second one, the 3 isn't going to give us an extraneous because there's no y attached to it outside. Y minus 4, again, is going to give us a positive 4 as our extraneous. And then the last one, the 2 is not going to give us an extraneous because that's in the numerator. And so that's 2 over 1. So that's not giving us an extraneous. All right, let's go for the LCD. So all I'm looking at is the denominators. The 2, again, is 2 over 1. I'm not worried about that 1. It's not going to change anything. So my LCD, the 3 comes down, and then the y minus 4, I only have to write once, and because it's in different fractions. All right, so now we're going to multiply everything by 3 times y minus 4. If you don't want to show it, that's fine. You don't have to show this multiplication, 3 times y minus 4. If you need to show it to each one, then show it to each one. There's nothing wrong with it. So on the first one, the y's minus 4 is cross off, but don't cross it off if you're doing it this way because you got to realize that you're distributing. So the y minus 4's go away, and I'm left with 3 times 3, which gives us 9. On the second one, everything crosses off. Again, don't cross it off if you're showing it this way, but everything crosses off. So that just leaves us with -4. On the last one, nothing crosses off. So I've got 2 times 3 times the y minus 4. Well, that's going to give us 6 times y minus 4. So now I want to go ahead, get rid of my parentheses. So I have 9 equals -4 plus 6y minus 24. Now I combine my like terms. So I have 9 equals 6y minus 28. So I'm going to add 28 to both sides. So that gives us 37 equals 6y, which divide by 6, that's going to give us y equals 37 over 6. Again, don't forget to do that comparison with the extraneous, and it doesn't match. So that ends up being your answer. Now, again, not every time will it not match. There will be some occasions where it does match. So you do need to check every single time. And if it does match, you need to cross it off. If there's no answers left, then it's no solution. If there are answers left that don't match the extraneous, then those are your solutions. So if you have any questions, don't hesitate to email me or come by and see me during office hours. Have a great day.